So let's talk about a really simple example, which is transforming features. And why would you do that? What are we trying to gain? Well, we may want to improve their distribution properties. For many machine learning algorithms, having distributions that are closer to normal distributions may be an advantage. And so there's ways we can transform the feature that may be skewed or have some other distribution get closer to normal. We may also find some transformations that make that feature more covariate with the label. And notice I don't say more highly correlated, because that relationship could be highly nonlinear, which may have low correlation, but still be highly covariate in some transformed space. So what are some common single feature transformations? So these are operations we can apply to a single feature. We can use logarithms, exponentials, square roots. We can compute the variance, the mean, the median, etc. Those could all be ways to transform a feature. We can do other operations that use several values of the feature. The above, like log, exponential, square root, just use a single value. But we could take the difference between one feature and the previous, or a feature value in the previous one, especially if they're like time ordered or something like that. We could use a cumulative sum. Again, generally you do that with time ordered data. And something to keep in mind, nonlinear transform, almost all the transformations I'm talking about here are nonlinear. And so nonlinearly transformed features are not going to be collinear. That is, they're not going to necessarily have high correlation with their original one. If you have a feature and a numeric feature and its square value squared, they're not going to be that correlated. So you don't have to worry about introducing new collinearity between the features so much. So people are often worried about that point. That's why I'm talking about it. But generally, that's not such a big problem.